Hi everyone and welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. We're doing this one question at a time. Here is question 1. Which expression is equivalent to x plus 3 squared plus 4 times x plus 3 minus 5? So I'm just going to do this down here so we have some more room. And I'm going to start by expanding this x plus 3 squared. So we're going to get x plus 3 times x plus 3 plus, and then this will leave the same, 4 times x plus 3 minus 5. So now we could FOIL out this x plus 3 times x plus 3 plus 6x plus 9. And then with this 4, we're just going to distribute this. So we'll get 4x plus 12, and then we still have that minus 5. Now we could combine like terms, and when we do that, we'll get x squared plus 10x. And then we have these whole numbers, 9 plus 12 minus 5, which will give us 16. And now we can factor this using product sum. So the product is 16, the sum is 10, and we'll end up getting 8 and 2. So we have x plus 8 times x plus 2, which is choice number 2. Question number 2. Which value to the nearest tenth is an appropriate solution for the equation f of x equals g of x if f of x equals 5 over x minus 3 and g of x equals 2 times 1.3 to the x? So I'm just going to use the calculator for this question. I'm also, since we're going over how to get the answer, I'm just going to graph it out on the side here, which you don't have to do on the test, but just will help us better see what's happening. I'm going to graph these one by one. So first let's plug in f of x is equal to 5 divided by x minus 3. And you'll see that we get something like this. And this is f of x. Now let's graph g of x. 2 times 1.3 raised to the x. And you'll see we get something like this. And we want to know the value of x where they intersect. So we want to know this point right here and what x is right here. So to do that, we're just going to use the calculator again. We're going to go to second, calc, go down to intersect, and then this may take a little playing around with, but just make sure we get to this area so we get both functions. So we're right near the point of intersection. And you could see they wanted it to the nearest tenth. So if we just round this to the nearest tenth, this will be 3.9, which is choice number 2. Question number 3. Which equation is graphed in the diagram below? And then we have all these different answer choices. So notice that the periods are all the same. So I'm going to want to focus on finding the amplitude and the vertical shift. Okay, so if we look at, to find the amplitude, what I'm going to do is just kind of look at this midline, this horizontal midline at y equals 5, the horizontal midline, and just notice how many units this graph is going up and going down. So if you look at this, we're going 1, 2, 3 units up, and 1, 2, 3 units down. So that means the amplitude is going to be 3. So already, if you look at the answer choices, we can cancel out choices 3 and 4, which have 5 as an amplitude. Now, the vertical shift up is 5, because that's the only answer choice left, right? If that's the case, then we know this is going to have to be a sine function. So if the vertical shift is up 5, usually a sine function always starts at 0, but because we shifted it up 5 units, it's now starting at 5, which means it's going to be choice 1. So just to get a little clarity on that, I'm just gonna like sketch out on the side so we were reminded of what y equals sine of x looks like and what y of negative sine of x equals looks like. So sine of x looks like this. We start at 0 and it looks like that. And negative sine of x is going to be the opposite of that. Kind of like everything's topsy-turvy, but now notice we're still starting at 0. And when you think of a cosine function, you actually start at 1 or -1 if it's negative. So that's how we know that this answer is going to be choice 1, -3 sine of pi over 3x plus 5. And if this was confusing and I went over too fast, please check out, I have videos that go in depth on how to graph trig functions and can explain in detail how to do this. Question number 4. Which point is in quadrant 3 and is a solution to the system below? And then we have these two functions. So again, I'm going to do a little sketch on the side here, and let's just go over a reminder of the different quadrant names. So they go counterclockwise starting over here. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we're going to be looking for quadrant 3. So we're looking over here. So now we could use our calculator again and just plug these two functions in. So I'm going to go to y equals, and we have the first equation we have is x squared minus 24. Let's see what that looks like. So it looks something like this. And now x minus 12. So we can't totally see it, so I'm just going to adjust the view here. So if you go to window, we can make that y minimum smaller. So here it has -10, but let's make it -25. So we get this picture here, y equals x minus 12. Notice we have our 2 points of intersection here, but the only solution that they're interested in is the one in quadrant 3 over here. So let's go back to our graph and let's see what that is using the intersect function. So second calc, and then just make sure you're in the right place because you could find the wrong one in the wrong quadrant. So we have the first curve, and then we have the second curve, and the answer here is -3, -15, which is choice number 2. Question number 5. For which equations will the value s equals 4 making the statement an identity? So let's look at one over here. So I'm just going to expand this, 2x minus 3 times 2x minus 3, and then we want to see if it's equal to what they have here, 4x squared minus 3. Now they're saying that this s is equal to 4, and it would be true. So let's plug in 4 for s. Okay, so now let's solve the left hand by FOILing. And we get 4x squared minus 12x plus 9. So we want this to be equal to that. So let's see, 4x squared, 3 times 4 is 12, x plus 9. So this works out. So choice 1 works out. Let me try number 2 on another piece of paper so we have more room. So we're taking x minus 2 and going to expand it, x minus 2 times x minus 2 times x minus 2 because it's raised to the third power, and setting it equal to x minus 2 times x squared plus, they have this s here, we're going to put 4x plus, and then they have another s plus 4 again. So let's focus on the left hand side and see what we get. So we're going to FOIL these two binomials. So this FOILing these two, you get x squared minus 4x plus 4 times x minus 2. So we have an x minus 2 on this side. So now we just need to see if this matches this, using when we plug in those 4s. So we have x squared plus 4x plus 4. So be really careful here because it almost looks like they match, but if you look closely, this has a minus sign and this has a plus sign, so they don't match. And choice 2 is not an identity, so only 1. So this is choice number 1. Question number 6. The number of bacteria in a sample which can be modeled by an exponential regression is shown in the table below. Assuming this trend continues, approximately how many bacteria would be present 8 hours after the observation began? So to do this, we're going to be using the exponential regression equation, y equals a times b to the x, and we're going to be plugging in numbers from the table into here to find the value of b. So this is the only value we don't know. A is always the initial value. And in this case, X is going to be the number of hours. So how do we know what to plug in here? So I'm going to plug in these numbers for Y and X. And then this is going to be, so this is 0 represents before any hours have gone by, right? So no hours have gone by yet. Therefore, 40 is going to be our initial value. So our initial value is 40. And then we're going to be using this pair to represent number of hours, X, and Y. So we could just plug in and find B. So 48, which I get from right here, the number of bacteria after 1 hour is equal to the initial value, which is 40, times B. We don't know what that is yet, we're going to find it, and to the number of hours. So when we have 48 bacteria, it's after 1 hour. So all we have to do here to find B is just divide 48 divided by 40, and what you're going to get is B is equal to 1.2. So that's not the answer they're looking for though, right? We found B, but what we're going to do is use this formula to find how much bacteria there are after 8 hours. So we're going to use the formula 40, the initial value, y equals 40 times 1.2, we just found, raised to the 8 hours. And then we could just plug that in our calculator. So when you do that, this question's a little weird because when you plug this into your calculator, you're going to get something like 171.99. And if you look at the answer choices, there's nothing like that here. But the key word here in the question is that they said approximately. So you want something as close as possible to that. So you're just going to go with 168, which is the closest number to that. Question number 7. Factored completely, x to the 4th plus 4x cubed minus 9x squared minus 36x is equivalent to what? So here we're going to be factoring. So I'm just going to write this down here. So the method I'm going to be using here is factor by grouping. And what we're going to do is group together, separate this into two different parts of the equation. And now we're going to focus on this part and just take out the GCF. So between x to the 4th plus 4x cubed, the GCF, greatest common factor, is x cubed. And what we're left inside the parentheses is x plus 4. And now let's focus on this, minus 9x squared minus 36, and take out the GCF over here. And here we get 9x. Inside will be left x plus 4. So notice we have these two matching. These should always be matching inside. So we have x plus 4, x plus 4. And what we're going to do is take the outside and combine them. So here we have x cubed minus 9x. And then these two that are the same, we're just going to bring them down, x plus 4. So we combine these two and then just brought this one down. So we're not done yet. Notice this can actually be reduced even more. So if we could take out another GCF, we could take out an x, and then inside we'll be left with x squared minus 9 times x plus 4. And then this actually can be taken out even again. So here we're taking the GCF out. And then here, what we're going to do here, this could be difference of two squares, or dots. So based on difference of two squares, we're going to have x plus 3 and x minus 3, and then we still have that x plus 4. So here's our answer, and when we look in the answer choices, we'll see that choice number 2 is our answer. Question number 8. The solution set for the equation x plus 1 is equal to radical 4x plus 25 is what? So I'm going to write that over here. So to solve anything with a radical, we're just going to square both sides. This will get rid of our radical. So this will give us x plus 1 times x plus 1. And then over here we could just drop the radical altogether, 4x plus 25. So now we can distribute this and then just bring everything to one side. And now we can factor this. We have x squared minus 2x minus 24, so we could just do the product sum. When you do that, we'll get minus 6 and plus 4. So before we say our answer is 6 and negative 4, let's just check our numbers and make sure that they fit in correctly into here, because these radicals can be tricky, and we just want to make sure that it's right. So we'll have a little check for each. So if we plug in 6 to the original equation, we'll have 6 plus 1 equals 4 times 6 plus 25, and this is all under a radical. So 6 works out. So now let's try plugging in negative 4. So here, because this was a negative and this is a positive, negative 3 does not equal to 3. So x equals negative 4 does not work out. So our only answer here is x equals 6, which is choice number 2. Question number 9. If f of x is represented by the graph below, which translation of f of x would have imaginary roots? So the thing about imaginary roots is they happen when a quadratic equation is kind of like hovering over the x-axis without touching it at any point. So imaginary roots, so this clearly has real roots because it's touching the x-axis. So something with imaginary roots looks something like this, where it's hovering and doesn't touch the x-axis anywhere. So if you think about how to get this to look like this, we're going to want to move the whole parabola up, the whole quadratic equation up by at least, let's see, 1, 2, 3, 4, at least, so it has to be greater than 4 units. So if we look at any of these, the only one with a vertical shift up, so we're going to need a vertical shift up, greater than 4 units. So the only one that counts as that is choice number 3, because it has a vertical shift up of 5 units. So these two are horizontal shifts because we're adding or subtracting 5 units to x. And then in choice number 3, we're adding 5 to the entire equation. So these are vertical shifts. This is a vertical shift. And then this is a vertical shift, but it's going down. So this wouldn't help us in making imaginary roots. So that's why choice 4 is not our answer. Question number 10. The solutions to the equation 3x squared minus 4x plus 2 equals 2x minus 3 are what? So, okay, so let's combine like terms here and get everything to one side. So because this coefficient is greater than 1, I'm going to use the quadratic formula, where a is going to be 3, b is negative 6, and c is 5. And now we just plug everything in. So x equals negative b. So the first thing I always like to do when it comes to quadratic equations is plug in everything under the radical first. So we have 36 minus 4 times 3 times 5, which gives us minus 24. So now this minus 24, we're going to have to do something with that negative, and it'll have to become I. But we could also reduce it even more, because this can be separated into radical 4 and radical 6. So this radical 4 could become 2, so we'll get 6 plus or minus 2i radical 6 all over 6. And now we could just reduce this even more. You could see that 6 divided by 6 is 1 plus or minus, and then we have 2 divided by 6, which will give us I radical 6 over 3. So this is really like 1/3, and then we have radical 6 over 3. So we get 1 plus or minus radical 6 over 3i. And if we look for that answer choice, we'll see that it matches up with number 2. So I have the I before, they have it in the a plus bi form, put the I after. So that's the only difference here. But question number 11. A culture of 1,000 bacteria triples every 10 hours. Which expression models the number of bacteria in the sample after t hours? So because this is an exponential function, we're going to be using the exponential formula, which is a times b to the x, where a is always the initial value, which they say is 1,000. B is always the rate, which you know is going to be 3 because it triples every 10 hours. So we know that it's going to be tripling. And then x is always the time. So the time in hours, which they gave us t hours, but it says it triples every 10 hours. So how do we know how many groups of 10 hours have gone by? We're going to be dividing hours by 10. So this little fraction shows how many hours out of 10 have passed. So if we put this all together, we have 1,000, our initial value, times the rate, which is 3, raised to the t over 10 hours, the group of hours of 10. So here's our answer. If we look at our answer choices, it's going to be choice number 4. Question number 12. An initial investment of $5,000 in an account earns 3.5% annual interest rate. Which function correctly represents a recursive model of the investment after n years? So recursive model. So recursives are a special way to write a sequence, and it's written in a particular notation. So the recursive formulas are always written where a sub 0 is the initial value, which in this case they tell us is 5,000. So if you look already at our answer choices, we know that choice 1 and 3 are definitely wrong, right? This is the kind of notation that recursive formulas are written in, a sub 0 and then a sub n. So a sub n is any term number, and we're saying that it's equal to, and then we need to figure it out. So they both have the notation a sub n minus 1. So what this represents, a sub n minus 1, is really just the previous term value. We're going to be doing, in this case, 1 plus r, because we want the value of the previous term plus the value of the previous term times the rate, which is 0.035. So 1 plus 0.035. So this is gonna give us 1.035. So we know our answer is gonna be choice number 4. So if you're still confused, let's run through this recursive formula and see how it works. We have a sub 0 equals 5,000. And then our first term is going to be 5,000 times 1.035. So if you plug that in, we get 5,175. And already this is looking correct, because if you take 5,000, multiply it times 0.035, you get 175. So with an initial investment of 5,000 and then plus the interest, so if we're adding the initial value, you get exactly what we're looking for. So let's keep going just to see how recursive formulas work and check everything out. So we're taking the previous term, which is now 5,175, and then multiplying it times that 1 plus r rate, and we get 5,356.125. So again, for the next term, we're taking the previous value, which we just got, and now multiplying it times 1.035. So this is just another way to write a sequence. Notice, right, we're getting all these numbers and they're following a sequence, but they're written in that recursive formula notation. Question 13. Which expression is equivalent to 2xy squared cubed root of x squared y? So we're just going to use the rule of exponents and radicals here. 2xy squared, and then we have x squared y, and this is all under the cubed root. So what that is equivalent to, it means that this x squared is really x to the 2/3, and this y is really raised to the 1/3. And notice we can combine some like variables here. So we're going to have x, and this is really raised to the 1, but since this is in fraction form of 2/3, I'm just going to put this as 3/3 plus 2/3. And then this y, using the rule of exponents and adding fractions, I'm going to make this 2 into 6/3, so we can easily add it to 1/3. And now we're just going to add this together. So 3 plus 2 is 5/3, and then y is going to be 7/3, raised to the 7/3. And this is equal to choice number 1. 2x to the 5/3 times y to the 7/3. Question 14. Which statements must be true about the polynomial function k of x equals negative 2x cubed minus 11x squared minus 12x plus 9? And then they have all these different choices, Roman numerals 1, 2, and 3. So let's go through these one by one. Let's look at this first one. X minus 3 is a factor of k of x. So since it's in this form, we can actually do a quick synthetic division to see if x minus 3 is a factor of k of x. So to do synthetic division, I'm just going to take all the coefficients of k of x, negative 2, negative 11, negative 12, and 9. And then here I'm just going to take 3. And now we could do synthetic division. And what we're going to be looking for is if there's a remainder of 0. And if there is, then it is a factor of k of x. So to do synthetic division, we're just going to bring the 2 down and then multiply negative 2 times 3, which gives us negative 6. Then we're going to add these two together. Negative 11 plus negative 6 gives us negative 17. And just keep that pattern going. And you can see this is not going to be equal to 0. This is the remainder. Therefore, it's not a factor, so no. So 1 is not correct. Okay, let's try the next one. K of 0 equals 9. So here we could just plug in k of 0. So we're going to plug in 0 for all the x values. And notice these all cancel out because they're all being multiplied by 0, and we do end up with 9. So this works out. K of 0 does equal 9. So 2 is correct. And now we just need to see if choice number 3 is correct. So here is 1, Roman numeral 2, and Roman numeral 3. And this is going to be the same idea. K of x divided by x plus 2. We can do synthetic division here again. But instead of looking for a 0, we're looking for a remainder of 5. So we're going to write out all the coefficients of k of x again. Negative 2, negative 11, negative 12, and 9. And this time we're checking if minus 2 is a factor. And we're just going to do that same pattern where we bring down 2, then we multiply, we add, and notice this time we do get a remainder of 5, which is what they were looking for. They weren't asking if it was a factor this time, they were just asking if we give a remainder of 5. So we know that 2 and 3 are correct, which is choice number 3. Question 15. To prepare for lacrosse tryouts, Cole is increasing the amount of time he spends at the gym. This week he's spending 150 minutes there, and he plans to increase this amount by 2% each week. So we're starting with 150 minutes and then increasing by 2% each week. The amount of time in minutes that he plans to spend at the gym t weeks from now is given by the function a of t equals 150 times 1.02 raised to the t. In terms of a daily growth rate, the amount of time Cole is planning to spend at the gym can be modeled by the function what? And then they have all these different examples. So let's look at this function here that they give us. And remember what this represents. This represents the amount of time that he plans to spend at the gym t weeks from now. So this whole thing is weeks from now. But what are they asking for? They're asking for the daily growth rate. So how can we make this function into daily growth rate? So notice if you look at our answer choices, the initial value stays the same, but the growth rate is being adjusted. So we're going to do 1.02 and do something to it. So because this is weekly, what we can do is raise this to the 1/7, representing 1 day out of 7 days, 7 days in the week. And what's going to happen now to this t is that whatever we did over here, we're going to need to even it out on the outside so it evens out and they can cancel each other out. So we're going to make this 7t and adjust it. So now all we need to do is plug this into our calculator, 1.02 raised to the 1/7. And we get this long decimal here, 1.00283 raised to the 7t, which is choice number 4. Question 16. Mr. Zachary posts review assignments on the Beta Math website for his students. On his last test, 49% of his students used Beta Math and passed. Overall, 68% of his students used Beta Math. Approximately what percentage of Mr. Zachary's students passed given that they used Beta Math? So let me just start by labeling P of A, P of B, all that stuff. So first we have 68% of the students use Beta Math. So I'm going to call that P of B, or Beta Math. And then it doesn't give us a P of A, but it's saying on his latest 49 of his students used Beta Math and passed. So unofficially P of A is students who passed. More importantly, they gave us the value of P of A and P of B. P of A and B, which is 0.49. Right, 49% of students used Beta Math and passed, and then they also gave us 60% of students use Beta Math. So probability of Beta Math is 0.68. So now, what are they asking? Approximately what percentage of Mr. Zachary's students passed, given, so the probability that they passed, A, given that they used Beta Math, A given B. Passed given that they use Beta Math. So there's a nice easy formula for this that'll make this question super nice and easy. It's P of A and B all over P of B, which they give us right away. So P of A and B is 0.49, and then P of B of Beta Math users is 0.68. So we can just plug this into our calculator and see what we get. We get 0.7205882353. And they want to know what the percentage is. So if we just multiply this times 100, we'll get 72%, which is choice number 4. Question number 17. Given sine of theta is equal to 7 over 25 and theta terminates in quadrant 2, what is the value of tan of theta? So I'm going to sketch out a little graph here. This represents what quadrant each trigonomic function is positive in. Here all of them are. Here sine is tan and cosine. And this angle theta terminates in quadrant 2. So a reminder of the quadrants, this is quadrant 1, this is quadrant 2, 3, and 4. So it's going to terminate in quadrant 2 over here. So we get this nice picture here. This is a theta, and we know that sine is positive, and here the value of sine of theta is positive. So, okay, so let's write out some more things we're going to want to use. Let's write out SOHCAHTOA. And if you look at sine and what it represents, it's opposite over hypotenuse. So it's sine of theta is equal to 7 over 25 is the opposite over the hypotenuse. So in relation to this angle, the opposite is over here. This is 7. The hypotenuse is 25. And now they want to know what the value of tan of theta is. So we're going to need to find this value here because tan represents the opposite opposite, which is 7 again, but now over the adjacent, which we don't know. This value over here is the adjacent. So to do that, we could just use Pythagorean theorem. This is a right triangle, and we could just use Pythagorean theorem. We have 7 squared plus b squared equals the hypotenuse is 25 squared. And then we could just plug that into our calculator. So 25 squared minus 49, which is 7 squared, will give us 576. And then we're just going to take the square root of both sides to find the value of b. And we get b is equal to 24. So this side right here is equal to 24. So I'm just going to make that a little bit bigger. Just rewriting it over here. So we have 24, which we just found, 7, and 25. So the answer here is going to be 7 over 24. But be careful, because remember, this is in quadrant 2, and notice only sine is positive in this quadrant. Tan is not. So because tan is not positive, this is going to be negative 7 over 24. So that is choice number 1. So choice number 1 is our answer here. Question 18. A family-owned grocery store in New Hartford, New York employs 49 people whose ages are approximately normally distributed with a mean of 36 years and a standard deviation of 6.2 years. Ryan has been hired to work at this store. He is 30 years old. How many people who work at this store would you expect to be younger than Ryan? So if we have a normal distribution curve, we know that the population, there's 49 people, so n equals 49. The mean is 36, the mu. So I'm just gonna mark that on our chart here. Standard deviation, the sigma, is equal to 6.2. And they want to know how many people are younger than Ryan, and Ryan is 30 years old. So I'm just going to mark that over here. 30 is about here, and we want to know who's younger than Ryan. So everyone before Ryan and up to him. So we're going to plug this into our calculator. So we're going to have a lower bound of 0, and then the upper is going to be 30, Ryan's age. And then we have all this other information. So we could plug this into our calculator and we'll get a nice answer. So let's do that. So to do that, we're just going to go to second bars and then go down to 2 normal CDF. And then, so I already have this all plugged in, but the lower 0, upper 30, the mu 36, and then the sigma is 6.2. And then we just press enter. So we get this number 0.665866241. So if you look at the answer choices, that's not what we're looking for, right? What we need to do here is multiply this times the whole population that we're working with, which is 49 people. So that's all the people working there. And we'll get 8.1627. And we're just going to say 8 because we're talking about people. So choice 4 is our answer. Question 19. For the function d of x equals the cubed root of x plus 2, the inverse function is what? So to find the inverse of any function, there's just like a set of rules we have to do. So I'm just going to rewrite this over here. D of x equals cubed root of x plus 2. So the first thing we're going to want to do is to switch the x and y. So d of x is really y equals 3 cubed root of x plus 2. And the first thing I want to do is switch x and y. And by switch, I mean just rewrite. So instead of y, we're going to put x. And instead of x, we're going to put y plus 2. And now we're going to solve for y. So that's the next thing we're going to do. So to do that, to get rid of this cubed root, we're just going to raise this to the 3rd power on both sides. We'll get x cubed is equal to y plus 2. And now to solve for y, we just want to get y alone. So we're going to bring that 2 to the other side. So x cubed minus 2 equals y, which is choice number 4. And that's our answer. Question 20. Given f of x is equal to x to the fourth plus x to the third minus 3x squared plus 9x minus 108 and f of 3 equals 0, which values satisfy f of x equals 0? So what we're going to be doing here, the goal is to factor and find all the zeros of this big polynomial. So already they give you this, which means that 3 is going to be a factor based on the remainder theorem. So if we know that, we can actually start with 3 and do a little synthetic division to then factor this even further. So we know 3 is a factor, so we're going to start there. And then we're just going to do synthetic division, write out all the coefficients of this polynomial. And you can see we get a remainder of 0. Which we know we would get because we already know this is a factor. And now what we're going to do is rewrite f of x, knowing that 3 is a factor. So knowing that, we know we can write x minus 3, and then whatever is left under for our answer that we got with the synthetic division is going to be the rest of this polynomial now. And now notice this is all left over. This could be factored again, so factored even more. So I'm going to be doing factor by grouping here. So we're going to split up this into 2 different parts and then find the greatest common factor, the GCF of each part. So over here we could take out an x squared, and then over here we could take out a 9. And we're left with x squared plus 9, taking the outside terms times x plus 4, matching inside the parentheses. So this is x plus 4, this is x plus 4, so we're going to take that x plus 4. And then we're just going to bring down that x minus 3 that we found earlier. So this is all equal to f of x. And now we're just going to set each of these, we're going to set them each into 0. So if we do x minus 3 to find the values we're looking for, we'll get x equals 3, x squared plus 9 equals 0, subtract 9 from both sides, take the square root, and we're going to get x is equal to plus or minus 3i, because this is a negative 9, so you can't have a negative under a radical. And then lastly we have x plus 4 equals 0, and here we'll just get x is equal to negative 4. And these end up being all the different x values and all the different zeros that they're looking for. So we have x equals plus or minus 3i, negative 4, and 3. And when we look for that in our answer choices, we go back, you'll see that it's choice number 3. Question 21. The profit function p of x is found by subtracting the cost function c of x from the revenue function r of x. So let's just write out, they just gave us a little formula. So let's write it out on our paper here. So we have the profit function p of x is found by subtracting the cost function c of x from the revenue function. So we have r of x, and then we're subtracting the cost function from r of x. So minus c of x. Which function below represents the cost function? So we're going to be trying to find c of x, given that p of x is equal to this and r of x is equal to this. So we're just going to plug this in here, find c of x. P of x is equal to negative 15x squared plus 600x plus 60. And then r of x is minus 0.4x squared. And then don't forget we're trying to find c of x, so minus c of x. So now we're just going to bring everything to the other side of this equal sign so we can get c of x alone. So we're going to bring over this 0.4x squared. These will cancel out. And then over here, we're going to end up with minus 14.6x squared plus 470x minus 1140. And be careful here, so this is like the tricky part. On the right side we're going to be left with minus c of x. So we don't want minus c of x, we want c of x. So we're going to divide out this negative 1. And when you do that, everything's just going to, that was negative is going to become positive, and everything that was positive will become negative, and we'll get 14.6x squared minus 470x plus 1140 equals c of x. And if we look at our answer choices, we'll see that it's choice number 3. Question 22. What is the remainder when 4x cubed minus 3x plus 3 is divided by x minus 2? So this is a nice easy question. We've been doing synthetic division a lot in this test. So we're just going to do it again here. So this time we're dividing by 2. And then to get our coefficients, notice we have 4x cubed, but then there's no x squared. So we're just going to put a placeholder here with 0, minus 3, and then a 3. And then we'll just do synthetic division as normal. So we bring down the 4. 4 times 2 is 8. 8 times 2 is 16. 16 plus negative 3 is 13. Then 13 times 2 is 26. And then here, for the remainder, we're going to get 29, which is what they're looking for. So the remainder is 29, which is choice 4. Question 23. The parabola with equation 12 times y plus 1 equals x minus 4 squared it's asking all this information on the vertex, the focus, and the directrix. We have to figure out what's right. So the first thing I'm going to want to do is get this into y equals form and get everything onto one side. So we're dealing with 12 times y plus 1 equals x minus 4 squared. Get this y alone. So this is the equation we're going to be working with. And based on this, we're going to find the vertex, the focus, and the directrix. So just to have like our formulas handy, I'm going to write all the formulas on the side here. So we have y equals a times x minus h squared plus k. So this is a quadratic formula in vertex form. And when we're writing in vertex form, we can easily find the vertex, which is hk, and the focus, which is h comma k plus 1 over 4a. So based on this, we're going to find the vertex and focus of our equation here. So if we look at our sample on the right, our vertex is hk. So notice this is minus h. Here we have a minus 4. So we know that this is just going to be 4. And then k is just k. And here we have a minus 1. So this is going to be 4 minus 1. So as we go along, I'm also going to be graphing this, so we get a nice picture of what we're doing. Okay, so our vertex is 4, 1? 4, negative 1, so down this way. And we can sketch out a little parabola here. Because this equation is positive, we know that our parabola is going to be facing up. So it'll look something like that. Now let's find the focus, which is h. So our h is 4. And then there's a little mini formula here. It's for y value, it's k, which is minus 1, plus 1 over 4 times a, 4. And then a, this is actually a 12, sorry. This, which is 2. So this will give us 4, 2. So here we're at 4, and then we're going up 2. So our focus is at 4, 2. Now the thing about focus, vertex, and the directrix is if you have one, if you have 2 of them, you can easily find the other one because they're equidistant from each other. If we look at how many units the focus is from the vertex, it's 3 units away. 1, 2, 3. So knowing that, we can count 3 units down and find the directrix. 1, 2, 3. And the directrix is always a straight line. So 1, 2, 3, 4. So the directrix is y equals negative 4. So now that we have all the information about this parabola, let's go back and look at the answer choices and see if any of them are right. So the vertex is at 4, 2. So no, our vertex is 4, minus 1. Focus is at 4, minus 1. No, the focus is at 4, 2. Directrix is y equals negative 4. So yes, that is our answer. And if you looked at number 4, it says 4 units between the focus and directrix. So no, because there is 3 units. So choice 3 is our answer. Question 24. Jay is training for a bike race over 15 weeks. At the end of the first week, he has ridden 10 miles, and he is planning to increase his weekly distance by 9% each week. Approximately how many miles total will he have ridden from the beginning of his training to the end of the 15th week? So there's a lot of information here. It sounds like we're going to be doing a sequence and then summing everything together. So if Jay is training for a bike race over 15 weeks, and at the end of the first week he's ridden 10 miles. I'm just going to do a little X and Y table here where X is going to represent weeks, Y is going to represent number of miles Jay travels. So I'm going to start with 0, and that'll make sense in a bit. The first week, which we're going to say 0, is going to start at 10 miles, right? He's starting at 10 miles. And then he's going to increase his distance by 9% each week. So then the next week, he's going to do 10 times 1 plus r miles. 10 times 1 plus r, which is the rate he's going, which is 0.09. So if we plug that in on the calculator, we'll see that he's going to be traveling 10.9 miles the next week. Let's look at the week after that. So we're going to be taking this number, the previous number, 10.9 times 1 plus 0.09 again. So the same number times 0.09. We get 11.881. So we're going to do this all the way down. We're going to do this 15 times because they want it over 15 weeks. So we're going to do this all the way to 14 because we started at 0. And we're not sure what we're going to get, right? But we know that whatever it is, we're going to want to add up all of these values because they want to know how many miles in total he's ridden from the beginning. So we want to know this total is what we're trying to find. So another way to write that is in summation notation. If we start at 0 and then go all the way to 14 using this formula, because we're starting with 10, our initial value, and then we're doing 1 plus r, the rate we're increasing by each week. So this is going to be 1.09, and I just got that by doing a 1 plus r formula, and then this is raised to the x. So instead of listing out all the rest of these and then adding them together, which would take a very long time, we could actually just put this in the calculator. If we go to math, and then we're going to go up, go to summation, and then we could just plug in the values we made here. So we have x equals 0, and it's going to go all the way to 14. And the reason we're starting at 0 is because it's that initial value, and it's going to be in our formula, and it's already included. So we're not starting at level 0, we're starting at 10. So now we're going to plug in 10 times 1.09 raised to the x, and then press enter, and we're going to get 293.609. So that's how many miles he's going to be traveling over 15 weeks, which is choice number 4. So this is the end of part 1. Look out for part 2 coming out soon. Good luck and happy calculating! So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating! Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!